Nilesh Agarwal.
From Towards Scaling Inference. Towards Scaling Inference is a place where you can learn about ML deployments from zero to scale. We are very excited to have Raj from Credit Karma with us today. He's an experienced engineer with an MS in computer science and currently serving as a senior machine learning engineer at Credit Karma. At Credit Karma, he has been working on recommendation systems, risk modeling, and user engagement. Thank you, Raj, for joining us today.
Thank you. Thank you for having me.
Great. So Raj, to start the interview, we would first like to understand that what kind of business problems are you solving through AI?
So, I mean, we have a bunch of business problems so we have recommendations problems where we want to give the best product for best financial products for the users, members of Credit Karma, which kind of help them to get to the financial, next level, next step in their financial progress. So we have from recommendations, we have problems on recommendation side, then we have problems on fraud detection side, where you have financial products, like you have money financial products and all. So you want to give you want to reduce fraud and increase and also give better have better user friction, reduce user friction in that particular sense. So mainly the problems are on risk modeling, I would say, recommendations and fraud. Yeah.
Got it, got it. And how do you currently deploy these models in production? So do you work with managed services like Hugging Face, AWS, or have you built your own ML infrastructure from scratch? And would also like to understand the pros and cons of the approach that you have taken.
Yeah, so right now for the deployment and inference side, we have our own infrastructure per se. So where we have, I mean, in this particular environment, I mean, all of these are based out of Google Cloud Platform, but right now that's what the situation is. But the dependency on cloud platform is kind of less, where I mean the whole inference engine is actually maintained by us. Yeah.
Got it. And any like pros and cons that you would like to mention about the approach of building an infrastructure from scratch? The reason I'm asking this because a lot of people who are listening to this episode would be at the cusp of kind of taking that decision. So would love to understand the pros and cons in your experience.
Pros would be that you are less dependent on one type of cloud provider per se, and the other one is we have very specific needs in terms of inference as well. So it kind of evolved from previous use cases, right? So our model families, our model families also have evolved, right? Previously it used to be something else. We were on Spark ML engine. Now we moved towards TensorFlow, and then we have some hybrid we have some PMML models, we have bunch of model families, and also we have a lot of change between all of these as well. So they have we have very we have stronger needs for cross-platform interactions. So we kind of over the time that evolved, and it kind of is way more it performs way more well for the use cases we have. So that's one thing. So, but the cons, I would say, is obviously it comes with a lot of overhead in terms of management per se. You have to build your own systems for monitoring, for testability, for having an end-to-end so it needs investment per se. Obviously it won't happen overnight. If you were to do it in this particular fashion. So yeah.
Hmm. Got it. Got it. No, that makes sense. So just wanted to understand here, let's say first, and wanted to understand what are the kind of inference workloads that you guys work on, right? Are they more real time, batch, streaming, and like how have you built your own infrastructure to handle like each of these cases?
So the I mean, we have all the three use cases, but so the one which I was talking about is real-time inference, where we have that is completely managed by us. But batch inferences, we use GCP a lot for that. So we have uh, we use Dataflow for ours as primarily as our scoring engine per se. So and then yeah, so and then we have streaming pieces as well. We maintain our own. So we have from the feature side, we have a hybrid ecosystem where we use for some of the smaller loads and all. We use Feature Store, Vertex Pro. I mean AI Google's Feature Store.
Hmm. Well,
Uh, but primarily but that's a very small one, but primarily we have our own internal feature store and fact platform, feature maintenance platform, and also so that handles both your batch and also your streaming features per se.
got it. Got it. No, that makes sense. And in terms of the model sizes, right? Do you run most of the classification model on CPU or like GPU? What are the kind of workloads there are?
So right now we are quite heavy on CPU.
Okay.
uh, it's supremely heavy on CPU, but we are evaluating. So it's a cost versus this game, right? So GPUs are kind of costly. So so I mean, for some of the use cases, we are even evaluating GPU if it kind of like reduces our load and all. Yeah.
Got it. And so GPU is not much in production right now, if I understand correctly, right?
Yeah. Not much in production.
Got it.
Yes.
And in terms of like scaling on CPU, right? Let's say when you are deploying things at scale, what are the average model size like? Is it like in few MBs, few gigabytes? Like what's that range
Yeah.
around?
It's in few MPs. Yes.
Few MBs. Got it. So I think auto scaling must not be a very huge challenge, right? When let's say the load increases from your production and like more inference requests are coming in.
Yes, auto scaling is not a problem actually. Yes.
Got
So I mean, obviously it's all containers, right? So as and when the throughput needs are higher, we just scale them horizontally.
Got it, got it, got it. And like auto scaling probably takes like few seconds only, right? Because it's like
Yes.
smaller
Yes.
MB models. Got it. Makes
Yes.
sense.
But we have a I mean, we don't mess around with that particular thing a lot. We have one minimum set of clusters, like minimum set of workers in the cluster, and as if and when it goes really high, it just
Got it.
goes, yeah, higher. Yeah.
Got it. And is the like since you have built this whole infrastructure yourself, is like cost a huge perspective where let's say your
Yeah.
inferences are costing too much for the product, or would you like do you guys have plans for optimizing the cost or that? How do you think about the cost
Yeah,
of
so
underlying
it's in
infrastructure?
both ways, right? So there it comes with, as I said, it comes with overhead of maintenance as well. So teams have to be on call and they have to maintain the whole particular thing that nothing should go down. And also, because of it, we are kind of I mean, it kind of brings in a lot of challenges from testability and all of that, monitoring and all of that, right? So for us, uh model monitoring, and then all of these ad hoc pieces which come uh with uh any of these inference providers per se, like crowd providers, that sounds to be that is very I mean, it comes with a lot of umbrella of things which kind of help you uh do a bunch of debugging as well, right? So we are looking at those options as well, that how do we not we even if we compromise on cost a bit, it should be if we are getting a lot of value in other sections, then yeah, it's a
Got
good
it, got it,
yeah,
got it,
consider.
got it. And did you explore any like cloud functions or serverless solutions from Google, like where you don't have to manage the underlying infra?
We I would say, I mean, yes, but for some smaller use cases.
Got it, got it. And like any primary reason for if you evaluated it, not selecting it for like production workloads, by like was it
So
lacking
there,
in customize? Yeah, sorry.
yes. See, customization is one of the biggest pieces, and also model families, right? So we are heavy on PMMLs as well, and uh, right now, and if you take any cloud provider, they kind of are like, either TensorFlow or Torch or like these ones, right? So we have to create our own. So there is some overhead in terms of like, us trying them out as well. That we need some of our own customizations, and like, we need to put in some effort to do that. Yeah.
Got it. So you're saying the cloud functions and all, they're not as customizable. So that leads you to go to more about managing your infrastructure, right?
Yes.
Got it, got it, got it. No, this is super helpful. And in terms of like building so I'm assuming since these are not deep neural net models, right? There's nothing much in terms of optimizing the model. So do you also quantize or optimize your
These
model?
are
What
neural net models. Yeah,
okay,
so we have wide variety, right? Like we have some PMML models which are not like, which are basic models per se, and then we have neural network models, deep neural net models, deep and
got
wide, which are heavy in size and also like, are uh, uh yeah, I mean, which are big in size per se, some few MBs and also.
got it. And do you do quantization or let's say conversion to Onyx or these kind of formats? Or are you guys right now deploying it in the native
So
format wherever you train it?
so Onyx, no.
Okay,
Onyx, I mean, we use native TensorFlow deployment for TensorFlow models and all, like deep neural network models. But we have PMMLs, which is kind of like, so Onyx is something to consider as well. But yeah, I mean, we haven't looked in any Onyx per se in that particular site. Yeah.
got it. And was it like accuracy or any trade-off that you guys didn't go with Onyx since you already know about it and must have like
So
tried?
yeah, so it's like this, right? So I mean, our systems are quite heavy on Scala, and we came from, I mean, our legacy was in that particular side, Java and Scala world, and from there we took over a bunch of pieces. So moving on to Onyx, kind of like, and also there is like, all these models have some chains and all that logic is also
Hmm.
implemented. uh all that logic or customization is also implemented alongside model evaluation. uh so because of that, I mean, trying out any other pieces has its own like, overhead. You have to specifically cater some time, or like, to do all of those. Yeah.
No, I totally agree with you that at that point there's definitely a pipeline which you need to build from each of the model. Like if you are converting into any format or using any format, there's a significant amount of effort. So totally agree with that. So again, you didn't want to spend more time in like understanding the pipeline to convert and optimize because it's too much overhead, right? So I understand that.
Yeah.
Got it. Now, in terms of like scaling your inference, right? So just wanted to understand on that. Do you think the current setup of like managed services like Google and your own thing is good enough right now? Or do you think like as it scales, you would look for more solutions which like can help you get it more of a like a managed service or serverless kind of a thing?
So it depends on the solution, right? Like whatever solutions which we have seen are kind of very similar to what all of these cloud service providers are providing. Like, So you have, so it's I haven't seen a cross-platform per se a lot. So where you have in one single place you can put in containers for you can put in contain. I haven't seen such engines prominently, like where you have some clusters for where you can easily spin up TensorFlow clusters or Torch clusters or PMML clusters all at one place and automatically interacting with each other easily. Like, because obviously not all model families will be able to, I mean, not all data science mess around a lot. So, I mean, they need, you can't restrict them to use one type of modeling ecosystem, right? So in that particular world, you would want uh, you would want a place to get all the type of models at one place, and also, some way of adding some customization on the top so that you can interact with all of these clusters at one place. I didn't see any such one that easily. So all these cloud service providers probably, like, they focus on one or few types of models, and you can host them at multiple places. But all at once has not been, yeah.
Got got. No, this is super helpful. So if you see, an ideal service for you, to reiterate, would be something like a service where you can just deploy any PyTorch, TensorFlow, or even like your own ML, paddle ML models, right? And then basically, it could take care of everything else. It should be taken care by the system. If you find such a service, then it makes sense where you wouldn't want to manage the infrastructure yourself.
Yes.
So currently,
Yeah.
you're forced to do that because like there's no one standard way of doing that in cloud provider,
Yeah.
right?
Yeah.
Uh, yeah, so Raj, I have one question here. So, just before you mentioned that, you were talking about the challenges around monitoring and, observability. So, could you speak about maybe one of the challenges that you faced as a team and how did you go about solving it?
So working with your own kind of clusters, and then, like, your own this thing, you have to implement your own logging because mechanisms, right? So all the inferences which you are kind of doing, you want to log them. And also, obviously, after logging it, you would want to have some monitoring on top of it, that if something is going wrong, if something is drifting, if something is, like, not predicting as what it is supposed to predict, you need tools to identify those and flag those, and then take appropriate action, right? And if you are working with your own ecosystem, you have to build all of those out yourself. But if you have, if you are using cloud uh, providers tools and all, they come along with it, right? So they do feature drifts on it, and they do prediction drifts on it. So, and they also do uh, they also do mapping, like, this prediction drift might is correlation analysis, that this prediction drift might be because of this particular feature. So all of those, they come in pre-made, where you can also plug in your own on-call systems on top of it. So page duties or whatever, like, it kind of, it's a one single thing where you're getting end to end per se, where so you don't want to lose money because of, like, doing some you would want to catch the problem as early as possible. So all these cloud providers come with tools which can enable you to get there faster.
Got it. Got it. No, totally makes sense. And just one last question. So, can you share any best practices or tips, for other ML engineers who are currently looking to deploy their models in production, based on your experience?
So my experience would be to, based on my experience, refresh them as soon as possible, models and all. Try to bring in tools which kind of do model refreshes without intervention, without human intervention per se. Seasonality is kind of important, and stale models are not useful. So and put in a lot of I mean, I would say try to get to a place where once model is deployed, data science or anybody should never probably should see it after that. So, and that's kind of challenge. That's where all of our jobs are revolving around. But that would be the place, like, to start. That would be the vision, I would say, for any engineer to target per se.
Got it, got it. No, I think these are some amazing actionable piece of advice and experience that you have shared very, I would say, honestly with us. So really appreciate, Raj, and thank you once again for taking out time for the session. I hope the listeners are gonna, really take away some interesting things from the session today. So thank you so much once again.